So now we're looking at factoring. The previous problem, we were expanding, now we're factoring. So in this case, we have a polynomial that has 4 terms. There's only one way that you've been taught to factor a polynomial with 4 terms. Which method of factoring would we use here? Yes, Zara? Greatest common monomial. So the question is, what goes into 2x to the third, negative 16x squared, negative 8x, and 12? Violet? 2. So we would just factor out the 2. Now when you factor something out, it doesn't go away, it is still in the answer. So the 2 is going to end up on the outside. And I'm looking at this and I would much rather, I think it's a more interesting question if I just get rid of this plus 12. So I'm going to do that. All right, so by getting rid of this plus 12, is there another term that goes into all 3 of these terms? Yes? X. X. So X.
Wait, wasn't there a plus 12?
Thank you for paying attention. I just erased it.
Oh, okay.
Cool. There was, I just erased it. All right, so we are now going to divide all 3 terms that are orange terms by our greatest common monomial. So what is 2x to the third divided by 2x? X squared. All right. What is negative 16x squared divided by 2x? Finally, what is negative 8x divided by negative 4? Now, sometimes you need to be careful because now we have a monomial. We can't do much with a monomial. It's in simplest form. But we have a trinomial here. We need to make sure that we cannot factor that one, so let's double check. Is there a number that we can multiply together to get negative 4? That when you would add the same 2 numbers, you would get negative 8. Is that possible? No. No. So therefore, we don't have any additional factoring that we need to do. We're done. So that's an example of a greatest common monomial. All right. So how will we factor? Let's do this one next. How will we factor this one?
I know you.
What?
Difference of square.
I know you, you're a difference of squares. Jack, how did you know this was a difference of squares?
There's not a value, like, it's a, what is it called when it's 2? It's like a, well, also
binomial.
It's a binomial, and negative 144 can also be distributed into positive and negative 12.
Okay, so we have 2 perfect squares. C squared is a perfect square. 144, as Jack said, is a perfect square. And we are subtracting. Subtracting is finding a difference. So since we are finding a difference of 2 perfect squares, we have a
Difference of squares.
So what times what is C squared?
C.
We have 1 positive and 1 negative because that's the only way to multiply to get a negative. What is the square root of 144?
12.
12 and 12. And there we go. Yes, Sasha. That would not be correct because, and I'm glad you asked, if we add c minus 12 squared, that would be equivalent to saying c minus 12 times c minus 12. And we would have to go ahead and do our rainbows and smiley faces. C times c is c squared. C times negative 12 is negative 12c. So that's this one and this one. Negative 12 times c is another negative 12c. And that would be positive 144. So when I add these together, I would get c squared minus 24c plus 144. So no, they are not equivalent. Did I fully answer your question? Okay. All right. But in that vein, I feel like you had a premonition of the next problem.
Oh, I got you.
So we have d squared minus 16D plus 64. So the question is, there are two ways to do this. First, you can ask yourself, what times what is 64 that adds to 16? 8. So we would have D, what do we have, plus or minus? It does matter. Minus because our linear term is negative. So now we have two of the same terms. That is not the simplest way to write this. So what would our next step be? Tariq?
You can just make it into 1 minus 8 squared.
There you go. And this is a square binomial.
Wait. Oh, yeah, because you add d times 8, or d times -8 plus d times -8, which is negative 16d. And then that's the, yeah.
Okay. So in this problem, do we have a square binomial?
No.
No, because we have a negative and we have 24, not a square. So the question becomes, what times what is negative 24? That adds to negative 10.
Negative.
Addie?
Negative 4 and positive 6.
Negative 4 plus positive 6 is not negative 10.
Oh.
But you would get negative 24 when you multiply it.
No, it'd be negative 4 and negative. No. Oh, wait, actually, no.
Okay. Nina?
Negative 6, positive 4. Well, you do a minus 6, parentheses k plus 4.
Again, I want to know what times what is negative 24, but also adds to negative 10. 6 and 4 equals, when you add them, you get 10. But to get a negative 24, one has to be positive and one has to be negative.
Yeah.
Negative 6 plus 4 is 2.
Negative 6.
Brendan?
Would it be negative 12 and positive?
Because negative 12 times positive 2 is in fact negative 24. However, negative 12 plus 2
You have to
is negative. I've got the back page. All right. So does that make sense so far?
Yes.
Okay. So that is a quick factoring review.